I'm Anil Kumar. In this video, I'll relate half-angle formulas of sine, cosine and tangent ratios. We'll take up 7 examples. The strategies which we are going to take here will help you to solve questions related to advanced trigonometric functions, inverse trigonometric functions and also calculus. So let's begin with solving them one by one. The base here is the compound angle formula. So we'll basically use what is cos A plus B is equal to. As you know, cos A plus B is cos A cos B minus sin A sin B. Now if A equals to B, in that case I could write this as cos of 2A equals to cos square A minus sin square A, right? So I have immediately converted the formula to a double angle formula, right? Now you also know that tan A plus B is equal to tan A plus tan B over 1 minus tan A tan B. Now if one of the angles is pi by 4, since tan pi by 4 is 1, that is to say, what is tan pi by 4 plus x will be equal to? Since tan pi by 4 is 1, it will be 1 plus tan x over 1 minus tan x. Right, so that is the kind of formula you may get with pi by 4. So it is important to see how most of these questions related to pi by 4 will be done. Since we know that tan pi by 4 equals to 1, we get this kind of a situation. Right? And here, if I write cos in terms of sine, I get double angle formula in terms of sine, and if I write sine as cos, I get double angle formula in terms of cos, right? Now let us see how to use these formulas and prove the 7 important identities which I have taken on this page. So let's begin with the very first one. Cos x by 2 equals to plus minus 1 plus cos x over 2. So I've just shown you that what is cos 2a equals to, right? So cos 2a is cos square a minus sin square a. Now if I substitute sin square a as 1 minus cos square a, in that case we get cos of 2a equals to cos square a minus 1 minus cos square a, correct? Opening this bracket, we get 2 cos square a minus 1 equals to cos 2a. Bringing 1 to this side, we get 1 plus cos 2a equals to 2 cos square a. Now, at this stage, if I make a substitution, let us say if 2a equals to x, in that case a will be equal to x by 2, correct? So what I can do here is replacing 2a by x, I get 1 plus cos x equals to 2 cos square x by 2, correct? So I get 1 plus cos x equals to 2 cos square x by 2. Now this is also a very important relation which we are going to use soon, which is 1 plus cos x is 2 cos square x. Now in our case, since we want to prove what is cos x by 2, we'll take this to the right side, rewrite. So we have 2 cos square x by 2 equals to 1 plus cos x. Now dividing by 2, we get cos square x by 2 equals to 1 plus cos x over 2, and when we square root we get cos x by 2 equals to square root of 1 plus cos x divided by 2, and becomes plus and minus, right? So it could be both positive or negative. So I hope this part is absolutely clear. So we got this relation that cos x by 2 could be plus minus 1 plus x over 2. Now this value is decided based on the value of x, in which quadrant cos x is, right? Now let's see how to prove sin x by 2. We'll again begin with cos 2a formula, which is cos 2a equals to cos square a minus sin square a. This time we will write cos square a in terms of sin square a, right? So we'll get cos square a could be written as 1 minus sin square a. We already have minus sin square a here. Now that gives us 1 minus 2 sin square a, correct, is cos of 2a. Now bringing 2 sin square a to the left, we get 2 sin square a equals to 1 minus cos 2a. Now as I said, this is in itself a very important formula which we are going to utilize many times, right? Especially for proving those 7 identities. Now let us isolate after substituting a as half of x, right? So if I substitute 2a equals to, let us say, x, in that case a is going to be x by 2, right? So a is x by 2 for us. So we could write this as 2 sin square x by 2 equals to 1 minus cos x. Now let's take it to the left side and prove what we want to, right? So we have 2 sin square x by 2 equals to 1 minus cos x. Dividing by 2, we'll get sin square x by 2 equals to 1 minus cos x divided by 2. Taking square root on both the sides, we get sin x by 2 equals to plus minus square root of 1 minus cos x divided by 2. Correct? So we got this value of sin x by 2 also. Now from here, you could easily get what is tan x by 2, correct? Now you know what is tan x by 2. It could be written as sin x by 2 divided by cos x by 2, right? So from the relations which we have just proven, it is 1 minus cos x over, that is the sine value. These 2 and the 2 in previous case will cancel, so we get 1 plus cos x, correct? With plus and minus. So you could also derive the formula for tan x by 2 from what we just did. Yeah, so basically, let me show you. So basically what we did was, we found cos x by 2 as plus minus 1 plus cos x by 2, sin x by 2 at that, and their ratio will give us tan x by 2. Now question number 3 is slightly different. We have absolute value of x by 2. Now let's look into this part. Now let's try to prove that absolute value of tan x by 2 is equal to square root of 1 minus cos x over 1 plus cos x. So let's begin with the right side, which is square root of 1 minus cos x over 1 plus cos x. Now the numerator 1 minus cos x could be written as 2 sin square x by 2, right? And the denominator could be written as 2 cos square x by 2. We've just shown that, right? Square root. Now 2 and 2 cancel, so you get square root of sin square x by 2 over cos square x by 2. Now square root always gives you a positive value, correct? Since square root always gives you a positive value, we can write this in absolute form, right? and sine over cos is tan, right? So this is basically tan x by 2. Does make sense. So that is the left side. So that is how you show this particular relation. So if we are given square root of 1 minus cos x over 1 plus cos x, in that case it is absolute value of tan x by 2, right? Remember, tan x by 2 is basically equal to plus minus square root of 1 minus cos x over 1 plus cos x. But if we are given square root of 1 minus cos x over 1 plus cos x, then it is always the absolute value of tan x by 2. Now let's take another relation, which is cos x over 1 minus sin x. And we need to show it that it is equals to tan pi by 4 plus x by 2. Now this is a very important relation. Let us see how to prove this particular formula, right? Now we'll use the double angle formula here. You know, cos 2a is equals to cos square a minus sine square a. So we could write, if I change 2a to x, we could write this as cos x equals to cos square x by 2 minus sine square x by 2, correct? Similarly, you also know what is sine 2a. Sine 2a is 2 sine a cos a. So sine x, where 2a is x, could be written as 2 sine x by 2 cos of x by 2, correct? So we are going to use these relations to show the result. Let's begin with the left side again. Left side is cos x over 1 minus sine x, right? So we have cos x over 1 minus sine x. Now cos x, as shown here, could be written as cos square x by 2 minus sine square x by 2 and 1 minus sine x. Now 1 could be written as sine square x by 2 plus cos square x by 2, correct? So we replace 1 with this, which is sine square x by 2 plus cos square x by 2, and minus sine x could be written as minus 2 sine x by 2 cos x by 2, correct? Now the numerator can be written as, this is difference of squares, right? So we could write this as cos of x by 2 plus sine of x by 2 times cos of x by 2 minus sine of x by 2. And the denominator is a perfect square, could be written as cos x by 2 plus sine x by 2 whole square. Minus, since this is minus whole square. Now one of these factors will get cancelled. So what remains here is cos x by 2 plus sine x by 2 divided by cos x by 2 minus sine x by 2, correct? Now in this equation, if I divide both by cos x by 2 or take common factor cos x by 2, what will become? So if I divide both by cos x by 2, or you can say if I take common factor of cos x by 2, either way, right? So either way we could do. In that case, what we get here is 1 plus tan x by 2 over 1 minus tan x by 2, correct? Now 1 could be written as tan pi by 4. So I could write this as tan pi by 4 plus 1 times, so we could write this as tan, this is tan x by 2, right? Divided by 1 is, we'll leave this 1 as 1 itself. See how we manipulate the result. So we'll read this 1 as 1 minus, we will write 1 is tan pi by 4 times tan x by 2, correct? Since we know that tan pi by 4 is basically 1, right? So multiplying by 1 doesn't make a difference. But this could be written as tan pi by 4 plus x by 2. You get an idea, right? So that helps us to write this in the given form. So cos x over 1 minus sin x can be written as tan pi by 4 plus x by 2. Now this is a very important derivation. I would like you to go through this once again, try to understand, and then do the next question yourself. So now we have a very similar question, just as we did. Cos x over 1 plus sin x this time should be equal to tan pi by 4 minus x by 2. Let's do this now. So cos x, as we did, could be written as, so we'll again start with the left side, which is cos x over 1 plus sin x, correct? Now cos x could be written as cos square x by 2 minus sin square x by 2 divided by 1 could be written as sin square x by 2 plus cos square x by 2, and sin x could be written as 2 sin x by 2 cos x by 2, correct? Now at this stage, this is difference of squares, so it could be written as cos x by 2 plus sin x by 2 times cos x by 2 minus sin x by 2. Denominator this time is with positive sign. So what we get here is cos x by 2 plus sin x by 2 whole square, right? A square plus b square plus 2ab, right? Now, one of these terms cancel. So what we get here is cos x by 2 minus sin x by 2 equals to cos x by 2 plus sin x by 2, correct? Taking cos x by 2 common, let me do it this time like this. We get 1 minus sin x by 2 over cos x by 2. Is it okay? Here also, if I take cos x by 2 common, I get 1 plus sin x by 2 divided by cos x by 2. Now cos x by 2, cos x by 2 cancel. So we have 1 minus tan x by 2 over 1 plus tan x by 2, correct? Now 1 could be written as tan pi by 4. So we could write this as tan pi by 4 minus tan x by 2 over 1 plus tan pi by 4, which is 1 tan x by 2, and that is equal to tan of pi by 4 minus x by 2, correct? So basically, I just want to remind you of what tan A plus B is. It is tan A plus tan B over 1 minus tan A tan B, right? If you have negative here, so it becomes like this. And what we also saw is tan pi by 4 is 1. So we utilize that to prove these identities. So I hope that helps, correct? Now, so we know this. Let's go and move on to the next one, which is tan pi by 4 minus x should be equal to cos x minus sin x divided by cos x plus sin x. Now, we could start from either side. So if I start with the left side, which is tan pi by 4 minus x, I could write this as tan pi by 4 minus tan x over 1 plus tan pi by 4 tan x. Now tan pi by 4 is 1, so I could write this as 1 plus, instead of tan, let me write this as sin x over cos x divided by 1 plus, we get tan x, sorry, this is numerator is negative, 1 plus sin x over cos x, correct? Now, taking cos x as the common denominator, I could write this as cos x minus sin x over cos x plus sin x, correct? Whole thing divided by cos x, this whole thing also divided by cos x, taking this as a common denominator. So that actually cancels off, and what you get is cos x minus sin x over cos x plus sin x, correct? So that is what we have done in previous two examples. Now here is the last question. I would like you to pause the video, answer this on your own, and then look into my suggestions. So we have actually derived all the related formulas, so it should not be difficult for you. Let's begin with the left side. Now what is square root of 1 minus cos x? Rather, what is 1 plus cos x equals to, and what is 1 minus cos x equals to? 1 plus cos x, as you know, could be written as 2 cos square x by 2, right? Similarly, 1 minus cos x can be written as square root of 2 sin square x by 2, right? And the denominator, we get the same thing, which is square root of 2 cos square x by 2 minus square root of 2 sin square x by 2. Now, square root 2 could be a common factor, it cancels, and square root of cos square x by 2, we could write this as cos x by 2 plus sin x by 2 over cos x by 2 minus sin x by 2, correct? Now taking cos x by 2 common, we get 1 plus, I could write sin divided by cos as tan x by 2 as we did in previous questions. And here we get cos of x by 2 common, we get 1 minus tan x by 2, correct? Cos x by 2, cos x by 2 cancel. And to get this pi by 4, we are replacing 1 with tan pi by 4, right? So we could write this as tan pi by 4 plus tan x by 2 over 1 minus tan pi by 4. So multiplication identity. So multiplying by tan x by 2 keeps it tan x by 2. However, we can now write this as tan pi by 4 plus x by 2. Do you see that? So that is again a very important identity to remember. I'd like you to go through these once again, try to understand, and then we can have a couple of questions based on them. Thanks for watching and all the best.